Today we're looking at the last two types of quadrilaterals. They are trapezoids and kites. We're going to start by looking at the parts of a trapezoid, just like vocabulary, because sometimes they'll describe images to us and we really need to know what the parts are called in order to draw these things. A trapezoid is a quadrilateral that has exactly one pair of opposite sides parallel to each other. And in the trapezoid that I drew here, it would be these two sides would be parallel to each other. These are called bases. So we have a base up here, and we have a base down here. The other parts of the trapezoid are called the legs. We have a leg here and a leg over here. We also have base angles. You have pairs of base angles along each base. That is a pair of base angles that are in those corners along that top base, and you have another pair of base angles along the bottom base. So it's like they're all called base angles, but you really have like two pairs. You have one pair along the top base, one pair along the bottom base, and this is kind of a basic trapezoid. Now, we can have more special trapezoids, which might be like the isosceles trapezoid. That's pretty much the most special kind that you can have. You still have exactly one pair of opposite sides parallel. Those are still called the bases. And to be isosceles, it's going to have congruent legs, just like an isosceles triangle. Those are the legs. You have pairs of base angles, but now that it is an isosceles trapezoid, those pairs of base angles are congruent to each other. So this pair of base angles is congruent, and then at the bottom, that pair of base angles is congruent to each other as well. Now the angles from the top will add to 180 with the angles from the bottom. And in an isosceles trapezoid, the opposite angles, if you notice, have the same markings as the pair of consecutive angles. So kind of looking here and here, notice that that's the same as the two on the left side there. And so they are going to have the same relationship. And that's just kind of a special thing that you might notice. So like these are going to add to 180. Just like the consecutive angles along the side. Now, not all consecutive angles are going to add to 180 because if you notice along the bottom, these are consecutive angles, but they are not going to add to 180. So it just depends, are your parallel lines involved? Here's the parallel line set. Therefore, this one and this one add to 180. And then on the right side, that one and that one add to 180 as well. But being isosceles does have these matching base pairs along the top and the bottom, and so there's kind of more mixing and matching that we can do with those. Let's see, what else do I want to mention about this? Oh, in the notes we're going to be filling in shortly. The diagonals of the isosceles trapezoid are also congruent to each other. You can prove that through the use of congruent triangles. If you would like to see a proof about that, I can show you that if you just, love proofs and want to talk about that some more. Let's get into the details. If a trapezoid is isosceles, then each pair of base angles is congruent, and I was just mentioning that a minute ago. If a trapezoid has a pair of congruent base angles, then it's an isosceles trapezoid, but also if it has a pair of congruent legs, then it's an isosceles trapezoid. But I think they were going for like a forwards and a backwards of the same statement. And a trapezoid is isosceles if and only if its diagonals are congruent. All right. Let's look at some questions. So a lot of these questions are pretty basic. They don't involve a lot of algebra, but they will kind of give you the gist of the idea as far as trapezoids go. Remember, you have only one pair of parallel sides. This will give you consecutive angles along the legs of the trapezoid here that are going to add to 180 because they're same side interior angles for these parallel lines. So 180 minus 110 is 70. So we're able to find this angle here as 70 degrees. We also have the legs marked as congruent here. Since those are marked congruent, we're able to have some pairs of congruent angles. Along each base is your pair of congruent base angles. So we're able to fill in those other missing angle measures. So the measure of angle F is 70. The measure of G is 70 as well. And the measure of H is 110. And being a quadrilateral, all of the angles of this trapezoid should add to 360. Let's look at question 2. Question 2 has another isosceles trapezoid, which means that our base angles are going to match. So we're allowed to put the 68 there. We also have our parallel lines giving us same side interior angles, making those supplementary pairs. So 180 would be the sum of those two there. Subtracting 68 from 180 leaves 112. So each of these is 112. So we're able to find the measure of angle F over here to be 68, the measure of angle G to be 112, and the measure of H to be 112 as well. We did a mid-segment theorem before, but it was in a triangle, and it was that the mid-segment is equal to half of the base. Well, when you have a trapezoid, you have two bases. So the mid-segment of a trapezoid is going to be the average of those two bases. So looking at this drawing here, we could write this as saying that 1/2 of the sum of AB plus CD will give you MN, that mid-segment. Another way to see this would be to multiply by 2 on both sides, giving you that the sum of the two bases is equal to 2 times MN. So really, either way that you want to use this formula, that is what you're going to be doing. With that mid-segment, connecting those midpoints, it's halfway between those bases, and so it's going to be the average of their lengths. This first one, we just have some, basic question where it's just numbers. So we're going to be adding the bases together and dividing by 2, doing an average, and that will give me 19. So here the mid-segment is 19, and I know there wasn't instructions, but we were trying to find the length of the mid-segment. On the next one, they gave us the mid-segment, and they have some x's in here. So we're going to be solving for x in this question. Sorry that there's not really instructions for that. And we do have a mid-segment. We know that it's a mid-segment because it connects the midpoints of the two sides of the two legs. See how those congruent markings are along that, showing us that M is the midpoint. And over here, N has these congruent markings surrounding it. So we know that N is the midpoint. That makes it a mid-segment, and that makes that mid-segment equal to the average of those bases. So adding my bases together and dividing by 2 will give me my mid-segment. So I'm going to multiply both sides by 2. (17.1 times 2 is 34.2. Combining like terms, 10x plus 3.2 equals 34.2. And continuing to solve, I'm going to subtract the 3.2 from both sides, giving me 10x equals 31. And dividing by 10, x is 3.1. Now, in this question, they did have some decimal values given to us. Sorry about that. They had a decimal here and here. So if they're giving you a decimal value, you can give a decimal value back to that same place value. So 3.1 is a good answer for this question. So those are our basic isosceles trapezoid and trapezoid questions and mid-segment of a trapezoid. Let's look at the last quadrilateral we're going to be looking at, which is called a kite. Like the kite that you fly in the sky on a windy day. If a quadrilateral is a kite, then its diagonals are perpendicular. If a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. One thing I should add here is probably the definition of a kite. This is a quadrilateral with two pairs of consecutive congruent sides. So notice how these are congruent to each other, and then you have another pair of congruent consecutive sides. That is what makes it a kite. Now, the opposite sides are unable to be congruent to each other, and so it is not a parallelogram, not in the parallelogram family. It is different. The kite will have diagonals that are crossing each other in a way where they're making a right angle with each other. They are not bisecting each other, but one of them is bisected by the other. If you look at this picture, we can use congruent triangles to find out that this triangle here along the top will be congruent to this triangle along the bottom. We can use side to get there because they do share that side along the middle. And so we are able to know from that this diagonal from C to A is bisected by the other diagonal. In a kite, using, again, those congruent triangles, we would also know that these two angles are congruent to each other by CBCTC. So that is kind of how this other rule comes about, having that one pair of opposite angles congruent to each other. So be on the lookout for those things as you are doing problems involving kites. So here's our first question. We're looking for the measure of angle K, and if you notice, the kite here has these consecutive sides congruent. And the congruent angle pairs are always going to be between those sides that are not congruent to each other. So that's going to be at M and K. So we can solve for angle K here by knowing that those would be congruent to each other in a kite. Kites have some symmetry, like we could draw one line of symmetry down the middle. That can help you to identify those congruent angles. So the measure of angle K is 88 degrees. Looking at question number 6, if you kind of locate your line of symmetry for the figure, that may help you. Find your congruent congruent sides. And that line of symmetry is going to split where those are located, having one on each side of that line of symmetry. We can notice that these would be congruent to each other. So they are both unlabeled, so we can go ahead and label them with X's if you would like. We don't know what they are, but we do know they're the same. And we know that a quadrilateral adds to 360 degrees. So we know that 60 plus 50 plus X will add to 360. So doing some math here, we are able to determine that 2x will be equal to 250, and dividing by 2, x is 125. So the measure of angle K is 125 degrees. The last little bit of notes here, we have some statements, and we're going to determine if they are always, sometimes, or never true. A trapezoid is a parallelogram. That is a never. Trapezoids are only allowed to have one pair of opposite sides parallel to each other and therefore can never be a parallelogram. The bases of a trapezoid are parallel. This is true all the time. It's the legs that are not parallel in a trapezoid. The base angles of an isosceles trapezoid are congruent. This is one that I'm feeling a little bit wishy-washy on because there's two base pairs in an isosceles trapezoid. So like all of the angles are called base angles. And they're not all congruent to each other. So I'm going to say sometimes here. If you're talking about on the same base, then yes. But base angles in general, we need a little bit more detail to know this one for sure. That's why it's sometimes, because they might be talking about two that match, or they might be trying to confuse you and be talking about base angles along different bases. The last one, the legs of a trapezoid are congruent. Well, it didn't say that it's an isosceles trapezoid, it just said trapezoid, so I'm going to go with sometimes here. If that trapezoid happened to be isosceles, then this would be true. And that is our practice on kites and trapezoids. So those are easier compared to the other days.